So I've just learned what the keyword transmute does in Odin. I thought I'd make a video on it. So over here, you can see that I was looking at the string equals procedure, and it has the keyword transmute inside of it to give a sense of where this procedure is in case you want to look at it yourself. Wherever you've saved Odin, you can go into the base directory, into the runtime directory, and in here there is a file called internal.odin, and that is where this transmutes. Well, not where the transmute lives, it's placed everywhere else in the code as well, but the string equals procedure, you can find it in there. And because I was trying to learn more about strings, I just happened upon this myself. And I saw that it was transmuting the string values up here into raw strings, but I didn't fully understand what this was doing. I could kind of infer it was some type of cast, but I wasn't 100% sure what it was doing. And just to learn more in general, I do ask questions around other places. So I made a post on the subreddit for Odin asking about strings in general, but I also mentioned that I saw the transmute word and I couldn't quite figure out what it was doing. And this helpful user down here linked me over to the documentation. And it says here that the transmute operator is a bit cast conversion between two types of the same size. And that alone, for me, was enough to kind of fully grasp what was going on. But I thought I'd try to explain in my own words, from my own understanding. So the difference between this transmute and a regular cast. If I am casting something, in this case, I have a 32-bit value and I want to cast it into an integer that is also a 32-bit. So one of them is a float, the other is an integer. The difference between floats and integers is that the floats have the floating point number, so they can show decimal places, and the integer cannot show decimal places, it can just represent whole numbers. So when I cast the float into an integer, what I'm expecting to happen is I'm going to keep the value more or less. We know that we're going to lose the decimal part, I'm expecting the integer below to get the value 123. So when I cast something, I'm expecting the value to be turned from one type into this new type. However, down here, you can see I'm also transmuting y, the floating point number, into this new value here, z. And what I'm expecting for this to happen is instead of keeping the value, I'm expecting that I will keep the exact same bit pattern. So the value is going to change, but the actual bits and bytes of data that make it up should be identical to each other. So if we look down, not down here, over to the left, you can see, just to verify what I'm saying is true and what's actually happening, I just went onto some other website and I typed in the same value. This website takes in your decimal number that you print in and it gives you the binary representation of that as a float. So the value 123.456, this extra stuff is not needed, is represented by this value down here. And I've also commented that in the code up here. So if we to actually run this program, what we're going to expect to see is that x and y have more or less the same value minus the decimal place, and y and z will be completely different values, but we will expect the binary representation of them to be identical. Out of this file now, and then I just run this. You can see here that the value x is, as we expected, 123, but the value of y is, I think that's 1,123,477,881. But we can see below that, where I'm printing out the binary representation of these numbers, is that 123 is represented by this many ones and zeros. I'm going to assume that is correct. I've not actually verified that myself. But we can see here that the binary representation of y is identical to what we see here on the left of the screen. The 0, 1, the 4 zeros, 1, 0, followed by the 4 ones, 0, double 1, 0. Then we got 3, 1, 0, 1. Then we got two more zeros, 1. So yeah, that looks to be correct. And that is the difference between casting something into a new type versus transmuting it. In casting, you keep the value. In transmuting, you keep the same bit pattern. And there is one thing that is important to note about this, is if I went over here right now and I turn this into an I64, so an integer represented by 64 bits, and then I try to run this program again, that will be perfectly fine. You can see here that it has kept the value. That is because the 64-bit is more than capable of storing the whole float. Whereas if I was to change this transmute down here to be an I64, even though the 64 bits of this integer value will be more than enough to store the 64 bits of the 32-bit floating point number, Transmute expects the size of the objects to be identical. If I was to try to run this right now, I'm going to get an error. And it's going to say, cannot transmute Y to I64 over 8 bytes of data. So the amount of bytes that make up your object must be identical to each other. And yeah, that's about all I got on that. That is my explanation of what Transmute does in Odin.